Okay, there we go. Good morning, Michael. Good morning, Catherine. Hey, you. Listen what I... Anybody? Nope, nobody's trying to get in. All right, let's see if I remember this song. Nope, I can't remember the chords. Uh, all right, let's see if I remember. Tell me why everything turned around. Packing up, shacking up is all you wanna do. If I could, baby, I'd get... No, I can't do it. I can't play guitar and sing at the same time. Catherine, do you play guitar? Maybe, or even there. Michael, do you play guitar?
No, I don't.
What song do you really like on the guitar?
I really don't know.
Bruh. Good morning, Italy. Let's see if y'all know this one. Adventure time, come on, grab your friends. We'll go to a very distant land with Jake the dog and Finn the human. Fun will never end, it's adventure time. Do y'all know that one? Maybe. I see people are starting to come in right now. Good morning, Carla. Actually, I could do this. Haha. Good morning, Maria Enrica. Mm. I've been practicing this part. Oh, pues. Ba-da-ba-la-la-ba. I can't do it. Bamba chords. Oh, wait, what? I've been doing it wrong this whole time. Let's see. Wait. Why do I keep messing up? It's because y'all are watching me right now. I'm getting nervous. Oh my god. Bum, 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 bum. Oh my god. Bum, 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 bum. Bum, 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 bum. Ba-da-ba-la-la. I can't do it. I don't know the rhythm, the strumming pattern. Good morning, Shayla. Good morning, Miguel. Good morning. Who have I not said good morning to? Honesty, Iristi, Fatima. Good morning. Good morning, Brian, Bricia, Belinda, Angel. What time is it? Adventure time. Look at ourselves. Actually, you know what? It's 10:01. Let's go ahead and get started. Thank you all for being here on time. I will play guitar later because I'm still practicing it. Is it? I didn't know. So, um, our quote for the day is a little progress each day adds up to big results. So what this means is if you do a little bit of something each day, eventually all of it is going to come together and show you the big results. An easy example is reading. We're not asking you to read 5 hours a day. We're not asking you to read an entire book in a week. We're just asking you to read for 30 minutes a day. 30 minutes a day over the next 6 months will be more than 1,000,000 words read. So that's what we mean by a little progress each day adds up to big results. Maybe you're not turning in assignments. Even just working on half an assignment a day is better than not working on an assignment. But that's what we mean by a little progress each day adds up to big results. So our learning goals for today, and please write this down in your notebooks. I can use angle measures and side lengths to conclude that two polygons are not similar. So today we're going to look at what the heck even similar is, or a polygon. Polygon is just a fancy way of saying a shape. It's just a shape. We're also going to look at the relationships between, thank you for asking me about the link. Copy link address. I should probably let in the other people, right? Here's the link for our notes, if you want to follow along. But as stated, all right, somebody else is trying to get in. Cristiano. So we'll look at the relationship between angle measures and side lengths and similar polygons. Similarly, we're gonna, let me bring this up. You'll know how to decide if two triangles are similar just by looking at their angle measures, okay? So it looks pretty heavy today, and it kind of is, but I think y'all are gonna do fantastic. I know, I believe in you. Somebody just asked me if we have to copy this. Yes, I do want you to copy these learning objectives in your notebook, but I provided the link for you in the chat box so you can go to it when you have time, okay? It's okay if you didn't get to copy it right now. So now I want you to take a look at these two shapes right here. Let me see if I can use the pointer here. Yes, I can. So take a look at these two shapes right here. What do you notice between them? Let's see. Jade, can you please unmute yourself and let us know what do you notice between these two squares? Some observations. Jade, are you there? Okay. Michael, do you mind unmuting yourself and letting us know what do you notice between these two shapes?
They all have four sides.
They have four sides. Okay. What else do we notice? Let's see. Stephanie, can you please unmute yourself and let us know what's something that you notice between these two squares?
One's bigger and one's smaller.
One's bigger and one's smaller. And I really want to highlight that aspect of it. When we talk about two shapes, first of all, what does the word similar mean? What does it mean if two things are similar? Thank you, Catherine. The word similar means the same, right? It means the same. In mathematics, it means almost the same. The difference here is one is bigger than the other. And, ooh, I like what Bricia said. I think the little square is a scale factor of the big square by 8. Yeah, they're alike. So two shapes are similar if, let me write that. Two shapes are similar if one shape is a dilation of the other. I forgot my pen today at home, so I need to type out the stuff, which actually might be better for y'all, because I don't know if y'all can read my handwriting. These two squares are similar. They look the same, but one is bigger than the other. What about these two shapes down here? Are these two shapes similar? Does somebody want to unmute themselves and explain why they're not similar? No takers? Michael, can you say that out loud? I really do appreciate you saying that, but can you say it out loud verbally?
One is a rectangle and one's a square.
One's a rectangle and one's a square. Absolutely. And Jenny, I do appreciate you giving me a response. I'm gonna go ahead and post it here as well. One is a square and another one's a rectangle. So it's true. Both of these shapes have four sides. That is true. I'm not gonna say no to that. But notice how the square, it has the same side lengths, right? This little side length, let me use the color blue. This side length is the same as this side length, which is the same as this side length, which is the same as this side length. But rectangle has these two that are the same, but then it has these two that are the same. And notice how the colors are different. Red and green are not the same color. So two shapes are similar if one's a dilation of the other. So if you just see, hey, it's the same shape, it's just bigger, it's a dilation. I'm gonna post the link for the whatchamacallit, the notes in the chat box again. We had like 6 new students come in, so here you go. Let's take a look at these two shapes. Italy, what is one thing you notice from this square right? Oh, did I just draw? Oops. How do I go back? Oh, heck no. Oh, here we go. Italy, can you unmute yourself and let us know one thing you notice about this shape right here?
Each side is 2.
Each side is 2. Thank you so much, Italy. Each side is 2. Italy, call on somebody else. It can be anybody.
Enrica.
Enrica, can you let us know one thing you notice about this shape right here?
Each side also has 2.
Ooh, okay. So I'm gonna write that down. And you do not have to write this down. Each shape has sides that measure to what? I don't know. Let's just say 2. So each shape has sides that measure 2. So if I told you, hey, I have 2 shapes and they all measure 2 sides, most people would say, yeah, they're similar. I mean, they have the same side lengths. Why are these different though? Why are they not similar?
They have different degrees on every angle.
They have different degrees on every angle. The angles, thank you so much, Miguel. If we look at this shape right here, one of the angles measures 120. The other one measures 120 degrees. And then the little corners here measure 60. How much do these little squares measure? Does anybody remember how much they measure?
90.
90.
90. It's how hot it got last week here in Oakland. And I'm so glad the weather is not that hot anymore. Let me write that down actually, if I can. 90. All right. I think I can become an artist. Maybe work at DreamWorks. This is 90 degree. Bro, that looks like a 4. Each of the angles measures 90 degrees. And then if you look at the second shape, they measure different degrees. Does anybody know what this shape is called right here? It has a special name.
A rhombus?
Rhombus.
Is it a rhombus?
Yeah.
Oh, wow. GG.
You didn't see it?
I did not. Okay, so I know this shape as a parallelogram because 2 of the sides are parallel. And if you don't know what parallel means, that's fine. You'll know about what that means later in this quarter. But yes, it's called a rhombus. So let's look at the question. Priya says these polygons are similar because their side lengths are all the same. So Priya is saying they're the same. Sorry, they're similar because the side lengths are the same. But Claire says these polygons are not similar. So they're not dilations of each other because the angles are different. Who do you agree with? Do you agree with Priya or Claire? So in the chat box, please type out if you think they are similar or not similar. just type out in the chat box if you think they're similar or not similar. This is free participation points, and you're not gonna get called upon to explain your answer, okay? I'm just letting you know right now. You're not gonna get called on. I'm gonna ask for a volunteer. So this is free participation points if you simply just type out what you think, if they're similar or not similar. I want to appreciate Michael, Catherine, Shayla, Stephanie, Carla. So far, that's 5 people. And how many do we have in here? We have 23. Come on. 18 more, 17 more. Thank you, Bricia. Thank you, Maria Enrica. Thank you, Italy. Thank you, Valeria, Fatima. All right. So thank you, Angel. Does anybody want to unmute themselves and actually explain why they're not similar? By the way, I already gave the answer. They're not similar. They're not similar. But why? And I'll type it out. That's fine, Angel.
They're not similar because of the angles.
Are the angles the same or different?
Different.
Because the angles are different. Absolutely. These two shapes are not similar because the angles are different. Thank you so much for that. Thank you, thank you, thank you. If they were similar, the angles would be the same. Because it would just be a dilation. It would just be a bigger version of something. Moving forward, are there any questions? No preguntas. Okie dokies. So looking at this next one, we have 2 triangles. Did anybody catch my mistake?
Yes.
I need coffee. I just call these triangles. We have 2 rectangles. The little side measures 2 here. The big side, the little side here measures 4, and then this is 4, and this is 6. Are these rectangles similar or not similar?
Not similar.
Ooh, I'm gonna give you some time, okay? So I do want you to tell me if they are similar or not similar in the chat box, okay? So in the chat box, if you think they're similar, you're gonna write rectangles are similar because ... and you give your explanation. If you don't think they're similar, you're gonna write the rectangles are not similar because ... And the one thing, I'm gonna give you a hint, okay? There is one hint I wanna give you. 2 shapes are similar if they are dilations of each other, okay? So I'm just gonna put that word out there in the corner right here. So please take the next 2 minutes to write up a response. Do you think these shapes are similar? Sí or no? And then explain why. Type it out in the chat, but do not press enter. Or, okay, never mind then. Go ahead and press enter. Now I'm just gonna give you a heads up. I know we had Michael type out their response in the chat box. I had another student also private message me their response. Instead of looking at what students are saying, try to come up with your own reason, okay? So remember what a dilation is. Mm. I'll give y'all one more minute right now. All right, so if you have your responses typed out, remember it's okay if you're right or wrong, okay? I just want to see where we are thinking right now. Go ahead and type out your responses into the chat. They can either be public or they can be private, okay? So go ahead and press enter right now. Okay, okay. So I'm getting both sides of the arguments, which I love. I love it. I love it. So I'm getting people are saying they are dilations. One is just bigger than the other, so they're similar. Okay, I had a couple of students tell me that. I have a couple of other students saying they are not similar because the sides are different. So yes and no for both responses. A dilation, let me actually draw this rectangle. I'm gonna show you right now. Let me see, can I draw a rectangle here? Yeah, so watch this. This is this rectangle. Let me put it in this corner actually. Let's see if they are dilations. Jenny, can you please unmute yourself and tell me, are they dilations?
No.
They're not. Notice how I took this rectangle here, right? And if it's a dilation, just like a lot of you, when you post Instagram pictures or whatever social media y'all be using now, and you're trying to like resize the images proportionally correct, right? You do this or you make it smaller. It's not fitting. And I want to highlight what Catherine wrote in the chat. She sent it as a private message, but she noticed, hold up, hold up, hold up. Let me make this a little bit smaller. I'm gonna leave it right there. Notice how to get to 2 to 4, you have to multiply by 2. So then we think our scale factor might be 2. But Saul, what's 4 times 2?
8.
It's 8. This is a 6. It's supposed to be an 8 for this to be a similar shape. So these two shapes, although they are both rectangles, are not similar because the angles might be the same. They all have 90-degree angles, but the sides are not proportional. Let me write that. Sides are, I can't spell, are not proportional. The sides are not proportional. And what do we mean by proportional? There's a multiplier. The two multipliers here are different. Does anybody actually know what the multiplier is to go from 4 to 6? Yeah. It's supposed to be 1.5. 1.5 times 4 gives you 6. So two shapes are similar as long as they are dilations. And what do we know about dilations? Well, the angles have to be the same, and there has to be a multiplier. Taking a look at these two shapes, take a guess. Are they similar? Yes or no? Just type into the chat box what you think. Are they similar? Yes or no? Just by looking at it. Thank you, Shayla, for responding. Free participation points. And just so y'all know, the way I take participation is, first of all, if you go to class. Secondly, the number of times you respond into the chat box. So if you respond at least like 5 or 6 times during the week, you get full participation points. Thank you, Catherine. Thank you, Maria Enrica. Thank you, Italy. Thank you, Stephanie. Thank you, Bricia. Thank you, well, okay. Hopefully it's an actual response, Valeria. Thank you, Jade. And they are similar. They are similar, okay? This angle is the same as this angle. In fact, this is just a square on its side. It is an enlargement. Yes, this is an enlargement. Thank you for that, Catherine. I really do appreciate you using vocabulary from past lessons. This is an enlargement. So that this means our scale factor is bigger than 1. How much is it? We can try figuring out. Whoa, what just happened? Oh, that's 1. It kind of looks like it's 2.5 maybe. But nonetheless, recognizing that it is an enlargement and this is a dilation is all you need to know. So these are similar. These squares are similar. So before you start typing out answers into the chat box, let me tell you this right now. These two triangles are similar. They are dilations of each other. You need to figure out, well, what is a dilation? What is the multiplier? What do I have to multiply 4 to get 12? Or what do I have to multiply 3 to get 9? Or similarly, what do I have to multiply 5 to get 15? In the chat box, private message me your answer. Do not type it into the general chat box, okay? But I do want you, thank you for asking me that. I do want you to copy this in your notebook. I want you to copy the two shapes and the sentence. The scale factor is whatever you think the answer is, because, and then explain your response. Thank you, Maria Enrica, Honesty, Stephanie, Carla, Catherine, Bricia, for sending me an answer. It's okay if you still haven't gotten an answer. I'll give you another minute to try to think of what do you think your scale factor is? And for those of you who need a little bit of a push, look at the red numbers. From 5 to 15, what do you have to multiply to get 15. Thank you, Iristi. Oh, Michael. I said private message me, not put it in the general chat. Michael, do you know what Discord is? If I had admin status right now, I would put a mute on you in terms of typing. So you would have to unmute your mic in order to in order to talk. No, I'm playing with you. I wouldn't mute anybody. So let's see. Catherine, I really liked your explanation. Can you unmute yourself and let the class know what you think the scale factor is?
I think the scale factor is 3 because if you multiply 4 times 3 equals 12.
Okay, so I did anybody else like hear her lag, or is it my internet over here?
I heard her lag.
Okay, some of you are saying she lagged, some of you are saying it didn't lag. It is a music. What music is playing? There's no music playing. Anyways, thank you so much, Catherine. I saw your response you put in the chat. That's why I wanted to call on you. So literally exactly what she said. The scale factor is 3 because when you multiply the smaller triangle by 3, you get the bigger triangle, 12, 9, 15. What if I didn't know? What if I didn't know, for example, what if I didn't know what I had to multiply 5 to get 15? What if I didn't know what that number was? What can I do instead of multiplying to figure out what my scale factor is? Bricia, can you unmute yourself and let the class know what you think you could do?
What I think that you can do is divide.
Divide what two numbers?
15 divided by 5. And then it's
Ooh, you can divide 15 by 5 to get 3. Does that always work? Heck yeah, it does. It always works. If you want to find your scale factor, you can just divide the bigger shape by the small shape and figure out what your scale factor is. The reason it works is because, watch this. 5 times some number, we don't know what that number is, so call it K, is equal to 15. I know Mr. Gomez taught y'all this, especially because it was also a focus area. What's the opposite of multiplying by 5? Dividing by 5. Oh, I'm gonna sneeze. All right, I'm gonna do this actually. Yeah, dividing by 5. So if you divide both sides by 5, you get that K is equal to 3. Beautiful, beautiful. So now what's gonna happen is on the next problem, y'all are gonna have 2 minutes to find the scale factor. Y'all ready for this? Okay, I'll stop. I'll give you 2 minutes to find the scale factor. Once you find the scale factor, type it into the chat as a private message. Michael, that was meant more for you. I'm messing with you, man. No, but seriously, as a private message, send it. No. So what is the scale factor in this scenario? I'll go ahead and color code. So you know what sides correspond to what sides. Ooh, that's a word I hadn't used before, correspond. While you are all working on trying to find the scale factor, I'm gonna play the intro to La Bamba. Oh, that was horrible. It got untuned, unfortunately. It's okay to leave it as a fraction. Yes, it is okay to leave it as a fraction. You don't have to convert it to a decimal. You don't have to simplify that fraction. If you just want to give me the fraction itself, that's fine. Give you one more minute to figure out what the scale factor is. Y arriba, por ti seré, por ti seré, por ti seré. Yo no soy marinero, param, pam, pam. Yo no soy marinero. All right. Do I have a volunteer that would like to unmute themselves and firstly say what the scale factor is and then explain how you got the scale factor? Not all at once, y'all. Oh my God. I am being flooded with the amount of students that want to share out their responses. I think it's easier if I just call on people. Let's see, somebody who I have not heard from. I think I've heard from all the students. You know what? Let's see. Shayla, can you unmute yourself, please? Shayla? It's okay, just unmute yourself. I don't want to put you on my list of students who aren't responding and are gonna get a talking points message home. Going once? Going twice? Okay, hopefully Shayla lets me know why she's not responding. Let's see, just going up by the list. Saul, are you there? Okay. This is not looking good for participation here. Noah, are you there? Oh, you're back, Shayla? Awesome. Do you mind unmuting yourself? Just quickly unmute yourself. Okay? We're gonna go through this as a group. So the question was, what do you think the scale factor is? But if you didn't respond, I was gonna push you to get the answer.
I'm not sure what the scale factor is.
Perfect. So, don't unmute yourself. Leave yourself unmuted, okay? So let's look at 10 and 15, for example. I know we have to multiply 10 by something to get 15, right? Something times 10 is equal to 15. As an equation, that's going to look like 10 times k is equal to 15. Now, Shayla, what's the opposite of multiplying by 10?
Dividing.
By dividing by, yeah. Thank you, Maria Enrica. Dividing by 10, right? If you're multiplying by 10, then division by 10 would be the opposite. So we divide both sides by 10. This is a big old 1. So k is equal to 15 over 10, which according to a couple of days ago, I think it was last week, both of these are divisible by 5. So 15 divided by 5 is 3. And then 10 divided by 5 is 2. So our k is 3 over 2, which some of you typed into the chat as 1.5. So Shayla, again, please unmute yourself. What's the scale factor here? Shayla? Okay. So the scale factor is 1.5 because 10 divided, sorry, not 10. 15 divided by 10 is 1.5. And then some of you also went ahead and did the other ones. 9 divided by 6 is also 1.5. And 12 divided by 8 is also 1.5. So if you didn't know what the scale factor was or how to find it, this is one of the reasons why I want y'all to participate, even if you don't know how to do it. Participating forces you to pay attention. And I know from a lot of surveys that y'all have taken, the number one reason why you don't pay attention in class is because you get distracted by your phone or other things around you. Question. There's a scale factor involved, which means these are dilated. Are these two triangles similar? Free participation points here by simply typing yes or no. You're not going to get asked to explain. Thank you to those of you responding into the chat. Catherine, Michael, Honesty, Darelli, Angel, Bricia. So these are similar. These two triangles are similar because they are dilations. These are dilations, so automatically they are similar. So anytime you make a shape bigger or smaller, they are going to be similar. I want to take a look at the next problem here. What happens when we take the ratio of the vertical and the horizontal side? Maybe you know what the vertical side is. Let's let blue be vertical. Let's look at this first triangle here. Which side is the vertical side? Is it 3 or is it 4? And it's totally fine if you don't know. I would rather have you type into the chat, I don't know, as opposed to not typing anything into the chat. Remember, it's free participation points. I don't know. I'm literally giving you free points and most of you are not taking them. It's like somebody on the street giving you free money. Why wouldn't you take it? Actually, there's many reasons why you shouldn't take free money on the street. The vertical side is 3. Vertical means you go up or down. So vertical means up or down. And if you didn't know that, I would highly recommend you write that in your notebook. Vertical means up and down. Let me type that into the chat or into here. The next word we want to look at is horizontal. Number 4 is horizontal. Which directions do you think horizontal goes if vertical goes up and down? Left to right. Once again, if you didn't know that, please write it down in your notebook. Even if you know it, just write it down. It'll help you remember. And then the word ratio means a fraction. So when you take the fraction of the vertical and horizontal side, so it's asking us what happens if you take the vertical over horizontal. Well, let's take a look at this shape here. Miguel, what's the vertical side in this first triangle?
The 3.
Thank you, Miguel. Jade, what's the horizontal side in the first triangle? I'll say it again. What's the horizontal side in the first triangle? Oh, my bad. You typed it. I was kind of hoping you to mute yourself. Yeah, 4. Angel, let's look at the big triangle. What's the vertical side of the big triangle?
I'm pretty sure it's 6.
Thank you. And then Fatima, what's the horizontal side of the big triangle? Thank you, Fatima. I really like hearing y'all when you like unmute yourselves and you talk. I like it. 8. Now 6/8, both of those numbers are even, which means if I wanna, you okay, Valeria? Okay, I'll check in with you in a bit. So both of these numbers are even, which means you can divide 6 and 8 by 2. Your bog? Okay. So 6 divided by 2 is 3. 8 divided by 2 is 4. Valeria, please unmute yourself and tell me, what do you notice about this number and this number? What do you notice about the two numbers I circled in green? Valeria? Your mic doesn't work. Does anybody want to unmute themselves and just let us know what do they notice about the two numbers I circled? Or we're just gonna awkwardly sit here until somebody decides to step up and turn on their mics. All right, let's see. Who have not heard from? Maria Enrica, can you please unmute yourself and let us know, what do you notice about this number I circled and the second number I circled? Wait, I just realized, are you not able to see it on the screen? Yo, I am so sorry. I'm just realizing what's happening. And I want to apologize if this has been happening for a lot of people. My iPad went to sleep, but it's still displaying the last thing that it was displaying. Watch what happens when watch. Everything that I did while the iPad went to sleep displayed. I want to apologize to those students who I was calling on or like, I don't know what the hell you're talking about, dude. I don't see any green numbers. So that helps me actually understand why a lot of students were being quiet. So Maria Enrica, now that you look at these two numbers, this number here, right? We divided 6 by 8, the vertical length and the horizontal length. And we got 6/8, which is actually the same thing as 3/4. But now what do you notice between these two numbers? They multiplied by 2. Yeah, I mean, they got multiplied by 2 because the opposite was dividing by 2. But do you not notice how they're the same fraction? These are the same fraction, 3/4, 3/4. Two triangles, right? What do we know about these triangles? The triangles are dilations. We know they're dilations because the scale factor, as a lot of you said, it was 2. The triangles are dilations. So the triangles are similar. I can't spell similar, I mean are. So because they're dilations, the triangles are similar and the ratios are the same. When we take the ratio of the vertical length and the horizontal length, you get the same number, 3/4, 3/4. For the sake of time, I'm gonna save the rest for another day. In the chat box right now, this is today's exit ticket. The exit ticket is to understand whether it's to see whether you feel comfortable with this idea of like dilations and similarity. Somebody just asked me if we can use our notes, and you can. So the first question, I'm telling you, these two shapes are similar. You need to figure out what this missing side is supposed to be. And then explain how you know these two rectangles are similar. So I didn't get a chance to tell you what the two conditions are. So I'm just gonna tell you right now. The two conditions are same angles. The shapes need to have the same angles. And the sides need to be proportional, meaning there is a scale factor involved. So go ahead and find out what A is equal to. This is a exit ticket, so no sharing answers. Be sure to tell me those two conditions I just typed into the chat. I want to know if you're listening and paying attentively. And then for the second question, you're going to get full credit as long as you tell me whether you feel confident or not confident with. I can use angle measures and side lengths to conclude that two polygons, which is a fancy way of saying shapes, are either similar or not similar. And if you want to respond in Spanish, you're more than welcome to. When you are done with the exit ticket, you are free to go. Yes, that is correct. Thank you, Angel, for getting started. Thank you, Bricia and Brian, for getting started. Thank you, Fatima. Heidi, I see that you still haven't started on it. Honesty, you haven't started on it. Jade, you haven't started on it. Jenny, you haven't started on it. Thank you, Carla, and thank you, Catherine, for getting started. Thank you, Kevin, for getting started. Thank you, Maria Enrica, for getting started. Michael, thank you for getting started. Miguel, thank you for getting started. Noah, I noticed you haven't gotten started. Saul, Shayla, and Stephanie, thank you all for getting started. Valeria, thank you for getting started. And if you are finished, you are free to go. Here, I'm gonna type into the chat. Oops, what just happened? I'm gonna type it into the chat box again, in case you couldn't find it on Canvas. All you have to do is log in, okay? Angel, I can't tell you if you're right or wrong. Catherine, thank you so much for being here. Have a good one. Oh, by the way, I have office hours after my next class, so y'all are free to come. Have a good one, Catherine. Thank you, Heidi, Honesty, Jenny, for getting started. And then everybody else, as I said, I do have office hours after my next class. There is no math class tomorrow. We do have crew, okay? It's a minimum day. So I hope that you all do what you're supposed to be doing tomorrow. I will see you all mañana.